Okay, so we're going to talk about 45, 45, 90 triangles. And as you might already know or might have guessed, the 45, 45, 90 is just a reference to the angles. You have 45, 45, and a 90-degree triangle. You might also hear these called just 45, 45 right triangles, whatever. As long as you know what the angles are, you'll know what we're talking about. But this is going to be the 45, 45, 90 triangle and explain how the legs relate to the hypotenuse. Of course, with these two angles being the same, you have an isosceles right triangle, which is what this is, meaning that you have two angles the same and their opposite sides would also be the same. So in this case, the legs of the right triangle are going to be congruent to one another, and the hypotenuse is the same as taking whatever the distance for the legs are and multiplying it by square root of 2. That's pretty much it. That's how these relate, and I'll show a couple of examples to kind of show you how the numbers work. All right, for this type of problem, we have one of the legs given to us. We don't have that leg, but it'll be quick and easy to find. And we also don't have the hypotenuse. So we want to look for both of those. So let me mark them X and Y. And we have our little template that kind of shows us how all this relates. And we know that whatever one leg is, the other leg has to be the same thing. So that makes it easy to find x. X is just going to be equal to 5 because that's what the other leg is. This leg's 5, so that leg's got to be 5. And then for the hypotenuse, well, we can see over here that if this is A, then the same value, whatever value this is, gets multiplied by square root of 2, and that would be the value of your hypotenuse. So over here, how that all works out, we have a 5 for that leg. So y will equal 5 times the square root of 2. And that's just copying our little template over with numbers now, though. So instead of a, that's a 5. And instead of a here, that's going to be a 5 again. So 5 times square root of 2. Now, for this type of problem, we have the hypotenuse given to us, but we don't have either of the legs. It's a little bit different, but it's really not that bad. Just think about over here, if we were going to go backwards from a times square root of 2 to get to a, then we'd have to cancel the square root of 2 out. That's how you get a by itself. So to do that, it would be divided by square root of 2. How this sets up mathematically, we have a times the square root of 2 is equal to 10. And we want to get a by itself because we want to know what a equals. That's what the distance or the measurement of the leg is. So we want to know what a is. So all we have to do is divide by square root of 2. And we get that a is equal to 10 divided by square root of 2. The only problem with that is you can't have a radical under a fraction. You can't have a radical as a denominator. So I need to get rid of the square root of 2. To do that, it's not very hard. We're going to multiply the top and bottom both by square root of 2. By multiplying the top and bottom both by the same thing is the same as multiplying by 1. I'm not changing any values here. But what that allows us to do, if we multiply straight across, 10 times square root of 2 is just going to be 10 times square root of 2. But 2, or square root of 2 times square root of 2, obviously, is just going to be a positive 2. So how this all shakes out, we have a is equal to 10 times the square root of 2 over 2. One more thing here. This only happens if your hypotenuse is an even number. Since my hypotenuse is an even number, whenever I have it now over a positive 2, 10 divided by 2 reduces. 10 divided by 2 is 5, so My answer is actually 5 times the square root of 2. And that's the final answer. That's the simple radical form. Okay, for this example, you're basically doing the same thing. I did want to show you, though, what it looks like if our hypotenuse is an odd number. Last time we had an even number, so when we divided by 2, it reduced down. When you have an odd number, you still do the same math. You just don't do that last step where you reduce it. So we have, let me get my marker. We have a times the square root of 2 is equal to 7. We want to know what just a is. We want to know what the legs are. So divide by square root of 2, and I get that a is equal to 7 divided by square root of 2. Again, you cannot have a radical as a denominator. So we have to get rid of that by multiplying the top and bottom both by square root of 2. The reason you're multiplying by square root of 2 is for the simple fact that square root of 2 times square root of 2 gives you just a regular 2, just gives you positive 2. And that cancels it off the denominator. So when we do this, we end up having a is equal to 7 times square root of 2 is on top. You just multiply straight across. And then square root of 2 times square root of 2 is just 2. Since we have an odd number up here, that's not going to reduce. 7 does not divide by 2 evenly. So the final answer is just 7 times square root of 2 divided by square root of 2.